Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain. Alright, moving on to the slide 4. We're talking about evaluating our machine learning model here. We're gonna look at a few things. Generalization ability, and these two terms called underfitting and overfitting. So, let's start with test error. This is a way we measure how good our model is. It shows us how well the model can predict unknown or new instances. The goal here, obviously, is to have the smallest test error possibly. This prediction abilities for new stuff is what we call the model's generalization ability. And if the model mess up on this new instance, well, that's called
the generalization error.
Now, here's these things. There's usually more than one model that could solve the problem, but we want the Goldilocks model. Not too simple, not too complicated, but just right. A model with the right level of complexities can best reveal the patterns in a training set
and have the best generalization ability.
Moving along. Now we're going to talk about some method to boost the generalization ability of our model. First up, we've got these things called holdout method. What we do is split our training data into two sets.
One for training and one for validation.
Typically, we keep around 20% to 30% of our known samples tucked away for validation. Next,
we've got k-fold cross-validation.
Here's how it works. We randomly split the entire example set into k-separated subsets. Then, for each subset, we use all the other subsets to train the model, and use this subset for validation. We keep track of the prediction results for each example. Each samples in the validation sets. Once we've done this for each subset, every sample has predicted value. We then compare this predicted value with the real values to see how well our model did. The cool things about this method is that it uses every samples for validation. So its
accuracy is generally better than the holdout method.
Here we have a brief graph for you to interpret the concept. Training set, validation set, and test set. The examples, the samples are divided into training data and test data. The test data is the test sets, which is the part of data that needs to be predicted by the application model, and is the final service object of all machine learning work. In order to prevent the trained model from being
valid
only for the training data, the training data is generally divided into training set and validation sets. The training set is used to train the model, while the validation set is generally used to validate the model and doesn't anticipate the model training. So, moving on, we're still talking about improving our model's generation ability. We've got three key sets of data to work with here: the training sets, the validation sets, and the test sets. Remember, we've split our existing samples into training data and training sets and validation sets. We use training set to, you guessed it, train our model. The validation set steps in to test our model and make sure it's doing its job right. Once we're happy with how things are going, we can set our model loose on the test set and see how well it can make predictions. Let's break this down with an example. Take a look at the graph on the right. We've sliced our data set into three parts. First up, we've got training set. Check out how the data is distributed. From this, our model has trained itself to spot a star-shaped decision boundary. Inside that boundary, we've got circles. And outside, we've got triangles. That rectangles are the samples that model got wrong. Next, we use validation set to test the model and see if it's accurate. If it doesn't meet our expectation, we tweak the model a bit, but if it's doing well, we'll move on to the test set. This is where we see if our model can deal with good predictions even when it's dealing with a complete new set of data. Alright, we're wrapping things up now. Let's recap what we covered. First, we kick things off by getting a grip on what machine learning is all about. We dove into concepts on understanding how machines are trained to learn patterns and make predictions or decisions without being explicitly programmed to do so. Next, we worked through the general process of machine learning. We discussed how it starts with collecting and preprocessing data, then choosing the right model, training that model with the data, and finally testing and tweaking the model to improve its performance. Then we got our hands dirty with some real-world examples of machine learning. We saw how this concept applies in practice and got a taste of exciting possibilities that machine learning brings to table, from personalized recommendations to autonomous vehicles and so much more. Lastly, we focused on how to evaluate effectiveness of machine learning model. We learned about the importance of the model's generalization ability, how to avoid overfitting and underfitting, and different ways to position our data for training, validation, and testing. All in all, we have covered quite a bit of ground. Hopefully, you've got a better handle on the world of machine learning now. That's all for our first course. I'm looking forward to seeing you again in the next class.